Okay, so let's start today's session. In the previous class, we already discussed the okay. So let's share the screen and then we will continue our discussion. Okay. So we already find the average output voltage of the single phase half wave control rectifier. That is, we have to obtain that value is almost equal to 2 Vm by 2 pi into 1 plus cos alpha. Okay. So if we put alpha equal to 0, then you will get the almost similar result for the single phase half wave uncontrolled rectifier, that means Vm by pi. Okay. So similarly, we can find the average output current. So average output current, that is represented by I0. So that is nothing but V average output voltage divided by resistance. So average output current is average output current that is represented by I0 equal to V0 by R. I0 equal to V0 by R, that means average output voltage by resistance. Average output voltage V0 by resistance R. Okay. So just put here the value of average output voltage, that is nothing but Vm by 2 by 2 1 plus cos alpha. So just put here the value of Vm by 2 pi R by 2 pi R into 1 plus cos alpha plus cos alpha. So this one is your average output current. Means V0 by R equal to Vm by 2 pi R into 1 plus cos alpha. Okay. So similarly, you will find out another factor, that means power factor, ripple factor. Okay. Now we just try to simulate the circuit in Matlab and try to observe the output voltage of the waveform output current across the thyristor and voltage across the input supply voltage waveform. Okay, so just try to simulate that circuit in Matlab. So just this one open and close and open the Matlab. Okay. And open the Matlab. Just take some time for opening the Matlab and try to simulate the circuit. So first of all, you remember all the component required for simulation of the circuit. So just wait few minutes. Matlab is open. It takes some time. So just wait few minutes more for opening the Matlab. Yeah, so this is the first interface of the Matlab. Now we just create one new workspace where we can simulate the circuit. Take some more times. Yeah. So just type here simulink and create new workspace. Click on here. The simulink model. So create the new workspace where you can simulate the circuit. It takes some more times. Wait for create new workspace. And first of all, you remember all the component what you require for simulation of the circuit, so that you can track from the Simulink library to workspace. Then, the appropriate connection you will be simulate the circuit. So it takes some time. 4 minutes. Some time in the new workspace. Yeah, so this new workspace is created here. You maybe save this new workspace with some model name. We save as any particular folder where you want to place this simulation model. So I want to just place here in Simulink lab. Simulation lab. So we already create some model here. This one almost to model number 15. Model 15. Okay, so this untitled workspace is saved as the model number 15. You maybe see here that means untitled new workspace is same as the model number 15. Now we want to simulate the circuit here, so just to concentrate how we can simulate. So all the components you have to require to drag from the Simulink library to new workspace. Um, this one is your Simulink library where you maybe find some required block that means sync, total sync. So this is what we required for seeing the waveform. Add in 115 and go to the SimScap. Find here SimScap, and in SimScap you maybe go into Sim power system. Sim power system you will find out various type of component block, that means electrical source, elemental machine measurement and power electronics switching. So go for the electrical source. Various type of electrical source are available here according to your requirement. You may choose as this one is your AC current source, this is your single phase AC voltage source. So we just go on the click and add in module number 15. Times. Okay. So single phase AC source is now available here. Now you can go for the power electronics power system, power electronics. So various type of power electronics switches are available here. So now you use restar. Okay, let's see. So just add this one to the model number 15 and electrical element will be element. So various type of electrical element present here. So we just click on this RXC branch and add into the model number 15 and go to the measurement. So maybe add voltage and current measurement voltmeter, add it to the workspace and measurement of current meter add into the workspace. Okay. Now next what we required here, required the power guide, power operating of the power system. So, now just this is set place. If you don't know which block is placed in which Simulink component, that means you may directly type here and search. We got the power guide block. So this power guide add into the model number 15. The next one more component required the pulse generator. Okay. So just type here pulse generator and search. So pulse generator is available here. Okay. Generator. Now just click on this one and just simulate the circuit. To regards and just according to your circuit diagram, you just arrange the component in the circuit. just here source we place here and a scope is placed over here. Just connect the circuit diagram. First generator placed here. Circuit. Just control R. And then circuit. And this negative polarity of source is connected to the negative polarity of the load. Okay. Now you want to just connect the output voltage wave, current waveform and input voltage waveform and output voltage waveform. Okay. So just is now we just put here the pulse generator value. That means amplitude is suppose that put here 5 or 10, whatever you may want. And what is the period is your 0.02 plus 1 by 50 is your 0.02 and pulse width percentage is 50. So pulse delay in angle, suppose that we put 1 watt means the delay in put here in second. So we can put in second here, that means just 1 minute. So yeah. 30 divided by 360 degree to 0.02. Okay. So 30 divided by 360. How much if we consider phasing it is 30 degree. 30 divided by 360, 0.833 into 0.2. Let's do it on this. 40 divided by 360, 0.83 and 0.83 into 0.02, 0.166, 0.166 phase delay. If you want to phase delay 45 degrees, then this value will change. Delay in second. Okay. Apply. Okay. So this pulse generator is connected to the thyristor here. Now we want to measure the one here in the single phase AC source. You know that the peak amplitude of the single phase, that means how much? 230, 220 volt is 220 or 230 is your RMS value. So if you multiply by √2, then you will get the value of maximum amplitude Vm. Okay, that means 240 230 into root 2, that means 1.41. That means 324.3 maximum value for a single phase supply. Okay. 324.3 phase is 0, frequency we consider that 50 hertz, that is 50, and okay. Now we want to measure the input voltage waveform and output voltage waveform and output current. Okay, so we require this emitter is connected to here. This one right here. Then connect from this point to this point, and this point to this point. Now one voltmeter we want to connect across the input and one voltmeter across the output. So just create another voltmeter here. Just control R. Maybe connect from this point to this point. And one voltmeter across the output. So put it here. Now you want to, for the purely resistive load, so just change this load. If you select here branch, click here, you will maybe find out various type of component of the load. According to our requirement, we can just select load. Okay, so pure resistive, just click on resistance, and we just consider the resistance value as if you take any arbitrary value or by default value 1, whatever you maybe want. Okay, so if you put here 10, then any specific value of resistance can be put here. Okay, okay. So now this is your load, very resistive load. Now we just connect this voltmeter for the voltage input voltage waveform variation, output voltage waveform variation, and emitter for the output current waveform variation. For that, just click on the block continuous. Okay. So just go for the configuration parameters. Just click here, discrete. Take the sample time by default value 50 microseconds. And okay. Now just we three output terminal required for the scope. So just click on the scope. Just create 3 axes. If you click on the setting, number of axes, it will suppose that we according to your requirement is here 3. So just click on 3 and okay. So 3 axes we have created. Now you just connect and just move this out. So be easily visible. Okay. So first terminal is connected through this voltmeter 1 and through voltmeter 2 and output this emitter. So you maybe find out what is the actual power circuit connection. According to that, we just connect here in simulink Matlab. Okay. So just place here on the 0.3. Now if you click on the run, then your model will be compiled. So take some time for compiling your model. Yeah, if you click on the scope, then you will be visualize your output voltage waveform. So just and this one is your auto scale. So gate pulse provided according to that. So this is your input voltage waveform. Input voltage waveform added from here. So one cycle completed here, another cycle is completed here. This is your pulse generator output voltage corresponding to that. Okay. So similar things. The gate pulse at this instant right here. Gate pulse waveform. Okay. And one is the gate pulse waveform. You can check the value of copper. Where is the one? So you can verify here. Suppose that here pulse generator. So you can connect to 1 volt voltage across the this thyristor also. Okay. So if you consider that, suppose that 5 and 15 phase delay is 0.16. So if you consider that another phase delay angle, that means suppose that if you consider gate pulse provided at 0 degree. Okay. And click on the scope. Okay. Okay. So this is your sinusoidal input voltage. You observe this one, and this one is your phase delay. If you consider 0, okay, then your output voltage will got something like this one for the positive half cycle. This one is reverse bias from this point to this point, pi to pi. So you will get the output voltage is 0. You know. So this one is start conducted at gate pulse given that means at 0 degree. If you provide gate delay at suppose that 60 degree, okay. So corresponding to that, this value is changed. So just change your delay angle value. So this one is your output voltage, and similarly this one is your output current waveform. Okay. Same for the resistive load, same waveform as the output voltage waveform. Okay. Not changing further time. So this one, because they divided by 10, so this one it becomes 33 gas, 33 almost. Okay, because we consider the resistance value as 10. Okay, so this V maximum value you obtained almost 323.4. So if you divide by 10, then you will get almost 32. So you may be aware that this output current waveform is 32. If you consider phase angle delay 0, you know, if you change the phase angle delay compared to 0 to another value, then we just put here the value of pulse generator. That means here, suppose that if you want to put here phase angle delay 60 degree, so 60 divided by 360, that means 1 by 6, 1 by 6 into multiply by 0.2. So 0.2 divided by 6, you get how much? 0.02 divided by 6 equal to 0.033. 60 degree. So we put here 0.0033. Okay. So done and okay. So again, if you run this model, then click on this scope. Maybe okay. So this is the input voltage waveform. This is an input voltage at the angle of 60 degree. Gate pulse provided at the angle of 60 degree. Is not. So you will get from 0 to 60 degree, 0 output, because thyristor do not conduct until and unless we provide the gate pulse. Okay. So when you gate pulse provide, after that the output voltage you may obtain similar to the input voltage waveform. Okay. So you may be obtain that from this instant we get the output voltage and similar to the input voltage up to pi. Okay. So again pi to 2 pi is 0, and after 2 pi at this instant the thyristor becomes in forward bias. So now if you provide the gate pulse at the delay of 60 degree, at the delay of 60 degree, then you will get again the output voltage waveform as similar to the input voltage waveform. Okay, from this instant you may be obtained like this one, similar to input voltage waveform condition. Again you open that the maximum value is almost 323. Okay, and this is your output voltage, output current waveform, similar to the output voltage waveform for the pure resistive load. So we consider here pure resistive load, so output current is also similar to the output voltage waveform. So from 0 to 60 degree, no output voltage we obtain. So we also seen that the no output current flow through the 0 to 60 degree angle. Okay, and at this instant when you provide the gate pulse and thyristor start conduction, then again I0, that means output current start to flow and same as the output voltage waveform up to the pi. Okay, and again pi to 2 pi, no output current will be obtained, so that value becomes 0 from pi to 2 pi. And after the 2 pi, when the thyristor becomes in forward bias, and you gate pulse apply at the instant of 60 degree delay. Okay, so maybe obtain the value of output current from this instant and similar to the output voltage waveform of this one. Okay, so please be very careful to practice this type of simulation in Matlab. Lot of circuit you may be obtained. So you maybe change this value corresponding how we can change their phase angle delay. So output voltage we can control. Okay, so if we suppose that 1 voltmeter, if you want to measure the voltage across this thyristor, so one more voltage we can connect here. So one more voltage we can connect here. That means that controller. Okay. So means if you connect across this thyristor, okay, and just increase the scope axis here, we go to the setting and number of axes we increase as your requirement, that is 4, and okay, so 4 number of axes create here. Okay, now if you connect this voltmeter in this place, and now, so again, if you run this model and observe the voltage variation, now your model is compiled. Now if you click on this, so 4 axis will be created here. You again go for the auto scale. Okay, now, so this is your waveform for the voltage across the thyristor. Okay, so this one is your fourth one. Okay, that means this voltmeter is connected. This waveform is showing the voltage across the thyristor. Okay, so you may be observed that from this point, from 0 to delay angle 60 degree, that means up to this point, thyristor do not conduct, so you may be obtain the voltage that is similar to the input voltage waveform. That means this one similar to the input voltage waveform. Okay, so from this point to this point, you may be obtained. It is similar to the input voltage waveform. Okay, at this instant, when the thyristor start to conduction due to the gate pulse provided at this instant, so you will get the voltage across the thyristor is 0 up to this point. Whenever the up to which point thyristor is conduct. Okay, so up to this point, you will get the 0 voltage across the thyristor. Is it clear? Now, in the negative half cycle, you may be find the same waveform as the negative half cycle of the supply voltage. So this waveform is very similar to the negative half cycle supply voltage up to this point. Okay, so you will be observed that up to this point. And again, when at this instant you do not provide the gate pulse, so again voltage across the thyristor, you will get this similar to the input supply voltage up to this point. Okay, and again gate pulse provided this instant, so voltage across the thyristor becomes 0 from this instant to this instant up to this instant, that means to 4 pi. Okay, you supply the gate pulse. So at this instant, that means how much this one? This one is your 2 pi plus 60 degree. Is not up to this point is your 2 pi. Is not up to this point is your 2 pi. So 2 pi plus 60 degree this one. So from 2 pi plus 60 degree to 3 pi, you will get almost 0 voltage across the thyristor. Okay, so this is the waveform for the various component of the single phase half wave control rectifier. Maybe whatever the waveform I have discussed in the previous class. Okay, so that waveform you obtained here through the Matlab simulation circuit. Okay, maybe result verify all the component of the voltage across the thyristor, voltage across the output voltage and output current waveform. It is very simple. If you practice in Matlab, then you will be design all this. You know, so maybe change this firing angle delay for another value, and according to that, you have to just put their value. That means whatever you want to delay angle, that means 45 degree. So you have to convert in degree to second. Okay, phase delay, because you here provide data in delay, phase angle delay in delay second. Okay, So 45 degree divided by 360 degree into whatever the time period of the waveform, that means 0.02. So corresponding to that, you have to just put this value, and for that maybe you obtain different various waveform. Okay. So just we stop here. In the next class, we will discuss another things. Okay. So we stop here.